Hello guys and welcome back. In this video we are going to see what is VSX. VSX of Checkpoint Firewall. Full form of VSX is Virtual System Extension, a product that runs several virtual firewalls on same hardware. What that means, consider you have a purchase a Checkpoint Firewall VSX gateway appliance. With that appliance, you will have license facilities where you can have a multiple virtual firewall. So within one hardware, using one hardware, you will be able to create a multiple virtual firewalls, which we call virtual systems. So virtual systems like that, based on your license, you will be having different virtual systems. And these virtual systems, short form is VS and full form is virtual systems, can be act like a firewall. So one virtual system is nothing but your one firewall. So like that, you can have a multiple virtual systems, a multiple firewalls for multiple firewalling purpose. Basically, each virtual system works as a security gateway or a firewall, which typically protects your separate network. When packet arrives at the VSX gateway, so consider some packet arrives here, it sends that particular packet to a respective virtual system with or who's protecting that virtual network. It sends that traffic to the virtual system protecting the destination networks. So whatever the destination network we have behind this virtual system, and this packet is designated to that particular virtual systems behind network, this VSX gateway will forward that packet to that virtual system. For example, right now say packet 1 is destined for this virtual system. So this VSX gateway will send that packet here, and from here this virtual system will process that packet and return to the destination where it actually wanted to go. The virtual system inspect all traffic and allow or reject it according to the rules defined in the security policies. Now let's see how physical network topology without VSX will appear. So consider have a multiple internet network, and those internet networks are getting protected by different firewalls. So how the scenario will be? So this is what your cloud from where the internet connection will come. Then there will be your some external router from the service provider. Then after you have your firewalls configured. So consider this is a separate firewall, this is another separate firewall, and this is another separate firewall. All these firewalls are protecting their own separate networks, so which will look like this. So consider this is network 1, network 2, network 3. In a typical deployment with multiple security gateways, each protects a separate network. Each physical security gateway has interface to the perimeter router and to the network it protects. So if you notice, for these three different networks, we need to have 3 different firewalls, and traditionally without VSX we need to purchase 3 different firewalls, whether it's the same vendor or different vendor, or maybe the 3 different appliances from the same vendor or different vendor. The cost of the firewalling is increased here, and the burden, you can say, or the configuration times also get increased because of the configuring all these firewalls, setting all these firewalls and all those things. This is what we get from the traditional physical network topologies without VSX. But if you consider the VSX option here, this 3 firewalling functionality will be getting within one VSX gateway. So this is your one VSX gateway, and this one VSX gateway having these 3 different firewalls, for example, and using only one hardware, configuring only one hardware, setting only one hardware, you will be doing the same work what we are doing for with the topology without VSX. So this is the benefit what we get from the VSX feature of the checkpoint firewall, and this is what a brief overview of the VSX. Hello guys and welcome back. In this video we are going to see VSX architecture and concepts. Let's begin with what is the main components we will have or we will going to discuss here. Number one, we are going to talk about the complete end-to-end architecture where we have VSX gateway, communication with the management server, we have virtual systems, we have virtual routers, we have virtual switches, and the interfaces and the connectivity comes with them. Now, to begin with, let's start with a very important point, which is the role of the management server in VSX. A VSX gateway is a physical machine that hosts virtual network, virtual devices. Checkpoint management server plays very important role in VSX architecture and the configuration. Consider this machine is your management server. I can call it like a multi-domain server, MDS, or I can also call it like a security management server. Depending on your requirement, you're going to configure this thing. In environments like a big scale environment, you have MDS configure, and with a smaller size environment, we can use security management server, a single device for that management purpose. Now let's see the management server role in VSX. VSX gateways communicate with the management server for the purpose of deploying, configuring, and managing all virtual devices. This is your VSX gateway. In this VSX gateway, you have your virtual devices which you set up for various purposes. Now, to configure, to deploy, to manage all these virtual devices, for now I'm taking it as considering it as a virtual systems. It may be the virtual routers or virtual switch, whatever it is. So performing the deployment, configuration, and management activities for these virtual systems and of the VSX gateway as well. The VSX gateway must communicate with the management server for all those things. So the communication between the management server and the VSX is always must. The important thing, the SMS or MDS, multi-domain server or security management server, must communicate with the VSX gateway. Basically, a management server, security management server, or a multi-domain server connect to the VSX gateway and provide provisioning and configuration services for virtual devices located on the VSX gateway. We going to talk about this all VSX virtual devices later on, but for now consider these are the virtual systems which require a configuration to be deployed to work. Now the important points, we talk about the connectivity between the VSX gateway and the management server, or you can say the MP nodes, important nodes which you need to be keep always in mind. For one, there is no support to manage a VSX gateway when the management server is behind NAT. So if this connection however is behind NAT, then there is no support to have a communication or have the proper communication between the MDS and the VSX, because there is a no support as of now provided from the checkpoint to have this configuration in place. Means whenever you set up NATing for VSX gateway or management server, you need to take care management server or a VSX, they are not behind NAT. And we all know what is NAT, network address translation, and what happens in NAT, public to private, private to public IP conversation based on the various NATs available, right? And secondly, it is not supported to manage a VSX gateway when management traffic is protected or travel from virtual system. Example, this is behind the virtual system which is configured, or this virtual system is from this VSX gateway. Due to that, the configuration or communication between the VSX gateway and the SMS will happen from this virtual system, and that not supported for the management communication traffic. So it is not supported to manage a VSX gateway when management traffic is protected or travel from virtual system on the same VSX gateway. Virtual system only can communicate directly with the management server whenever there is a need. That can be possible. There is a constraint that this virtual system and this management server, they are not in. This management server is not behind this virtual system. Let's see what are the ways have to connect management server with VSX gateway. So again, consider this is your SMS or MDS and this is your VSX gateway. To manage this SMS or MDS and this VSX connection between them, there is two options available. Number one is locally managed connection. It's like a local management connection. Local management connection, we call it these two devices, appliances, VM, whatever it is, they are or under or within same geographical location, or I would say in same data center. Okay, so there will be the a physical connectivity between this SMS or MDS or VSX. This connectivity will be happening from special interface, which in a checkpoint term they call it DMI, stand for dedicated management interface, which will use to connect the VSX gateway to management server. DMI or a dedicated management interface, nothing but the actual physical interface, or you can say in a VM environment a virtual interface immediately assigned for the management traffic. There is no issue if this DMI interface having public or a private IP address. It's okay with that. Now let's talk about the second option. Here don't have the management server, the VSX, onto the same geographical location. Consider this management server I have where other geographical location, or a very distance from the VSX gateway. There will be the connection like this. There is some internet connectivity comes into picture, and then the connection to the VSX. So here the management server is not located within the same data center, you can say, where the VSX gateway is located. Type of arrangement is very useful when management server and the VSX are geographical different, which means when using a remote management server, security management server or a multi-domain server, the management traffic travel via an internet or external network to the VSX gateway by means of any connection via service provider or the any sort of routers. Example, the management server connect to the VSX gateway means of any routers connected to the VSX management interface. Activity is from some routers. In this arrangement also the checkpoint recommend that use a dedicated management interface. So this is how the arrangement is made up. Now let's move to the next topic here, and let's talk about your dedicated management interface and non-dedicated management interface. Dedicated management interface, which we just talk about, let's consider few important point about DMI. DMI uses a separate interface restricted to management traffic such as provisioning, login, and monitoring. It segregates management traffic from routing, production traffic. DMI uses separate interface that is restricted to management traffic such as provisioning, login, and monitoring. It segregates management traffic from routing, production traffic. Because of that, it enhances the performance, especially for the end users. Important note here is that it not support manage VSX when DMI is configured with VLANs. If you are planning to configure the VLAN interfaces, which we're going to talk about, it is not supported to manage VSX when the DMI is configured with VLAN. I mean, your DMI dedicated management interface configure with the VLAN tags, this configuration is not supported. Now let's talk about the non-dedicated management interface. There is a disadvantage while using non-dedicated management interface. One, non-dedicated management interface configuration, non-dedicated management interface configuration with interface deprecated and not supported. Remote management via virtual systems also not supported. Also, when we trying to configure such sort of provisioning, like login or the management traffic via non-DMI interface, your performance will drastically degrade. So you have to keep this in mind. Do not use non-DMI interface for your login or management traffic. Number 4, and the important one, the non-DMI, non-dedicated management interface is irreversible. You cannot change from a non-DMI VSX gateway to a DMI VSX gateway. Once you configure your interface for the management traffic from VSX to the MDS using non-DMI, that will be the permanent. You won't be able to reverse it. But one can use non-DMI to share internal or external interface which carries the basic traffic for the users and other than the management traffic. In this video we have understood what is the basic connectivity and the requirement to set up a proper VSX communication with the MDS and few components of VSX architecture. Next video we are going to see what are the actual virtual devices which we can configure in VSX and what are their purposes. Hello guys, in this video we are going to see VSX virtual components. We're going to see what is virtual system. We're going to see what is virtual router. We're going to see what is virtual switch. So let's begin with what is virtual system. Virtual systems is a security and routing domain that provide the functionality of security gateway with full firewall and VPN facilities. Virtual systems nothing but your firewall. Virtual system maintain its own software blades, interfaces, IP addresses, routing table, ARP table, and dynamic routing configuration. Each virtual system also maintain its own state table, security and VPN policies, configuration parameters, login configurations. This virtual system act like a firewall, and you can see on the screen you can create a multiple virtual systems That is the purpose of the VSX gateway, and you can use all these virtual systems for different customers. Consider virtual system 1 is used for, say, network 3, virtual system 2 is used for network 4, virtual system 3 is used for network 2, and virtual system 4 is used for network 1. Basically, these virtual systems are protecting a separate network, and this is what the benefit what we get from the virtual systems, like a firewall. And this virtual system individually handles all the firewalling work. Now, next, let's understand what is virtual router. So you can see on the screen, this is your virtual router. Virtual router is an independent routing domain within a VSX gateway that perform the functionality of physical routers. So in real world, if you see the Cisco routers, whatever the functionality provided by the Cisco routers, you can achieve same via this virtual router. So basically, whenever you want to route the traffic, you want to do routing between the virtual systems, virtual devices, you can use virtual router. Virtual router supports dynamic routing as well. Virtual routers perform routing functions. All sort of routing can achieve via this virtual router. It's like a physical router. Virtual router maintain a routing table. You will expect to get a routing table when you run this command in this router as well, with a list of routes entries which describes which network and direction he wanted to go. So like the Cisco routers, you will achieve that thing from this virtual router as well. So that is all about the virtual routers. Now let's see about the virtual switches. So if you see this part, this is called virtual switch. This virtual switch is L2 virtual switch, which connect virtual system and the virtual networks or the networks behind the virtual systems, and facilitates sharing a common physical interface without segmenting the existing IP network. So if you compare with the Cisco L2 switches, whatever the functionality you will get from that, you will achieve same from these virtual switches. Now we have spoke about virtual routers, virtual system, virtual switch. Now let's talk about the link which connects these three virtual devices together. We call it warp link. Basically, whenever you create these virtual devices, connection between these devices happen via a special interface which automatically create when you create these virtual devices. That connection or interface we called warp link. Now let's conclude with three key interfaces type for VSX. One we have external, one we have internal, and one we have sync. Depending on the setup, these three interfaces come into the picture. Dedicated management interface is also we call as a physical interface, but we already spoke about it, so we are not going into that. External interface, we call it like something the communication happen via external interface to the outside world. Internal interface, these are the interface which we connect our internal network, and the sync interface which we use for the clustering purpose. There are other interfaces which are also important. Let's talk about them. Number one, VLAN interface. If you have requirement to direct the Ethernet frames to a specific virtual system, then you can use VLAN interface. And in VLAN interface, this functionality we can achieve using VLAN tag. For example, consider VLAN tag 100 like this. On the ETH3, for example, what will happen? It will assign a virtual interface named, say, ETH3.100. So you will be getting a sub interface like this, and the traffic using this VLAN tag will reach to the destination which designated for this communication. Guys, there is a one more interface which also used in VSX. We call it unnumbered interface. So VSX let you reduce the number of IP addresses required for VSX network deployment when you use one or more virtual routers. You know, we discussed about this warp link. A warp link connected to a virtual router, and that warp link have a facility or a flexibility or a functionality to borrow an existing IP address from another interfaces. You know, instead of assigning a dedicated address to the interface which leading to your virtual routers, you can borrow those IP addresses. That capabilities what VSX provide, we call it unnumbered interface. Let's conclude this video with the management traffic. So as you can see on the screen, we have the management server here, which is located remotely, and we have a VSX gateway here, and this VSX gateway we have these virtual system. Behind these virtual systems we have these networks. Now whenever management server wanted to communicate to VSX gateway, or via management server we wanted to perform some configuration related activities or a VSX gateway, what happen, will initiate a communication from this management server. This management server's communication travel via internet internet router to the VSX gateway. VSX gateway give the instruction to the particular virtual system if it's required to communicate with these virtual systems, and from this virtual system we will do whatever the basic configuration we require to perform. Likewise, we can do the instruction to the virtual routers and virtual switch as well. So this is what the flow of the traffic if you want to communicate via management server, if the management server is at remote site.
Let's perform VSX gateway cluster installation using MDS. I am fast forwarding initial installation as we have already covered in previous video all these contents. You can see I am just performing checkpoint OS installation. In previous video we have seen MDS installation. In this video we are going to install two VSX gateway and perform the configuration from multi-domain server or MDS. You can select configuration requirement as per basic requirements for a particular installation. Now just follow me along and I will address you back once initial installation get completed. Now we have completed basic installation. Now do web UI. I'm just logging to the one of the gateway, and from here we are just putting the basic details: gateway name, DNS name, domain name, and all. And we will select security gateway as we are installing the security gateway. The video is little bit fast forward, but it's important to address these details. Now here you are seeing activation key. We need to put a secure internal communication for having a communication with management server to the gateway. So give a secure communication, secure password here, and keep this password in mind. And now just finish the installation with whatever the basic setting we have. So second gateway, we are just performing the initial configuration over here. So bear with me until this initial installation get completed, and I will address you back once this installation get complete.
It helps the speaker lead his audience into the scene he described by creating an imaginary picture. Usually it's something that moves.
So as you can see, both gateway installations completed. Now let's log into the MDS. I'm just logging to the MDS, and from MDS we will do the next steps. So select the MDS here. It will load the initial services, and we will divert to the MDS initial page. So yeah, it's loading the applications. It will load all the processes. Sometimes it takes time to load everything. Right now I can see all things got loaded. Now from here, as you can see, there is a domain which is global domain present, which is by default there. We don't have to configure that. And as you can see, there is an IP address 192.168.1.254, which is the IP address of the MDS server, and this IP address is the main IP address, I would say. Now the next step is that we need to create a domain. Domains are nothing but your security management server. They act like a security management server. So based on your licenses, what we have with your MDS purchase, you can create as many domains as we can based on the licenses. So here what I will do, I will create a domain, and from that domain we will log into those domain, and we will do the next setup. So as you can see at the top, there is a star. If you click there, you can see there is an option called domain. Select that option domain, and it will show you the what name you need to provide to the new domain. So here I am just providing the new name. Here you can click the add button, and you can define your different domain servers behind it. So you can see domain servers details. You can give the domain server details from here, and which is behind this MDS server. So if you see, there is a configuration, and there is a name here. If you give the name and the IP address, the one single domain will create. But I wanted to show you guys, there is an option where you can give the range, the IP addresses from which you can select the the domain by default. You can create those range, and out of that the IP address is select for the domains. So for that you have to go to the MDS object like this, and over there you need to edit. There's option edit, and here if you see there is something called set address. This is, sorry, the IP address. This is the main IP address, and if you go to the multi-domain, there is the range option, so you can provide the range here, which is your start IP address and the end IP address, how many IP addresses you want or how many domains you want typically. And once you provide that details, you have to click OK, and then you have to just come out of it. There is no much setting we need to do, as you can see. Just click OK, come out of it. Okay, taking time. Okay, now you need to go again back to that. Before that, there is something like popping up, it asking me to publish it, so you just have to click publish. So within this MDS, the publish will happen. It's basically saving the config what we have done. Now click to the star, then come to the domain. Here first you just give the name of your first domain, whatever you want, and then click add, and from there you see this IP, resolve IP. Just click to that, and from the range select that, and it will automatically pop up those IP address there. So this is what the basic domain what we have created. Now click OK and go to the trusted client option. Once you're there, you can define who can access your domain. For lab purpose, I am giving any access here, so anyone can access. For now, you have to just click plus sign now, and it's get added, so anyone can able to access. Now additional details, if you wanted to provide, you can give the name and all, but in my case it's okay, I don't want those now. And it's saying, are you want to continue, and we says yes. So at the bottom you will see the domain installation process is taking place. Let me just adjust the screen so you can see it, that domain installation is taking place. Let's wait couple of seconds. Once this installation complete, we'll resume. Let's wait. I think it's almost done. It's completed. Just confirmation is remaining. So it's everything is happening in background. So once it's completed, we will get the pop-up message that domain created, and I can see the message is there, the domain is created, and also we can see over there. So once the domain is created, you need to go to that domain, select that domain, and you need to launch smart dashboard, and then we'll work from there. So once you right click to the domain, you will see connect to the domain option, and once you click that, you will see the process starting to connect to the domain, and it may take couple of seconds depending on the configuration load. We have a new configuration, so it should not take much time. It's asking me now for the signature to verify to process, so it's okay to verify these details. So let's say proceed, and now it's getting connected, initializing the services, now loading the data. Let's load this application, and from there we'll see how we can configure the VSX gateway and a cluster. Now launching the application, I can see the application is launched. We can see this is the new console, smart console. Now let me go back. Now let's go ahead and create a VSX gateway object. So let's go to the start, then there is a option called VSX. Before that we will go to the clustering, because this is for the clustering lab. So VSX cluster, so there is something called VSX gateway, and then there is an option called cluster. So for this lab we'll be selecting the option cluster. Once you select the cluster property page will appear. There is a series of steps you need to perform. Just first give the cluster name, what cluster name you want to provide, VSX gateway cluster. Then you need to provide the IP address of that cluster. Then what product you want to use. We have basic cluster XL configuration, we have load sharing configuration. So here we are basically going with the cluster XL configuration. So I'm going with the basic shared interface option. Here you have to give VSX cluster members. So we already have 2 gateway installed. You need to give their details here. So prior to that I have to change the IP address here. I thought the IP address is already in use, so let's give say 192.168.1.12. Yeah, and now let's click next. Now depending on your requirement, your setup, you have to select these options. We already discussed these options on my last videos on the VSX installation labs, so you can refer those details. The same details we can apply here. Next, add the cluster members. So I am just putting the name and the IP address and the activation key for already set up VSX gateways. You need to have these gateways here. You need to put these details here so that your cluster will form for this gateways accordingly. And if you also seeing that we are establishing SIG with the gateway from here itself, so you can deliver this work as well, in spite of creating the VSX gateway object and setting the SIG between the MDS and the VSX gateway individually. You can do the same thing via performing the clustering configuration. So as you are seeing, this is quite simple, and these clicks away. Next, you have to select the interface that you need to share as a VLAN trunk. We don't have anything like that, so I am just moving ahead from this. I'm just clicking next. Here you can put your VSX cluster members. First provide which leading interface it takes, and then put the IP addresses of your gateways, IP address and the default mask. So I'm just putting both the gateway IP address and the default mask. Let's click next, and now select the interface with the virtual system to take, which is ETH1. Next, now select all these policies which need to be applied with this new setup. Click next, yes, and finish, and just wait for a couple of seconds to this clustering take place. It's completed, and you can see the process operation completed successfully, and we can close this now, and you will see the VSX cluster object already present, and we are seeing some licensing issue. That is fine because we are running on a demo environment. Okay, right now it's also got green. I believe it takes some time to collect the process. And this is how you can set up a VSX cluster. You can go ahead and perform the virtual system configuration. The steps are the similar, the one we already performed with the previous videos. I'm just following the same steps to configure this virtual systems. So just watch out the steps we'll be performing here for the virtual system curation, and once that is curated I will address you back.
Hello guys and welcome back. In this video we are going to see a VSX traffic flow management. So as you can see on the screen, I have a design talking about the VSX traffic. VSX processes traffic by according to three rules. So we are going to see three important rules now, how VSX processes the traffic. So number one rule, context determination. This is the number one rule, or you can say the way helps for the traffic management. So in context determination, VSX incorporates VRF. We might be heard about this term called VRF in Cisco world. VRF stand for virtual routing and forwarding. It's a technique which allows to create multiple independent routing domains. What that mean? So the technique which allows these virtual devices, consider this is a virtual router, this is virtual switch, this is virtual system. It allows these virtual devices to create multiple independent routing domains. What do you mean by routing domains? Routing domain is nothing but an entire routing for each and every communication, which includes all the communication initiated, destined, source, all things. So basically this routing domain, one routing domain designated for one virtual system or one virtual router, you can say. So individually in entire virtual entire VSX gateway, if you have a multiple virtual routers, multiple virtual systems, you will be having a multiple routing domain. And due to this routing domains, this virtual devices can uses overlapping of IP addresses. So if you have a limitation in IP addresses and you want to use them multiple times in different IP ranges, provided you are using for the internal purposes, or you have a separate network which is not overlapping each other, in that situation you can use this feature called routing domain to overlapping the IP addresses, and this entire context togetherly we call it a context. So the name itself is a context. So when the traffic arrives at VSX gateway, so whenever the traffic say this is your internet, from here when the traffic arrives at your VSX gateway, a process known as context determination come into the picture, and which helps to direct this traffic to the appropriate virtual system, virtual routers, virtual switch, accordingly the way you have done this setup. So consider you have a setup where you having your virtual routers in place, virtual switch in place, and there is no virtual router and virtual switch. I mean, three different scenarios. Let's consider number one scenario where you have a physical interface connectivity. Physical interface connectivity. You don't have a virtual routers, virtual switch in place. Whenever this packet arrives to this VSX gateway, based on the context determination, it will send that packet on a physical link to this virtual systems. So whenever a packet arrives from the outside world, and the packet will be on the dedicated link, and from this virtual gateway, virtual system extension VSX gateway, the traffic will forward to the virtual systems based on the configuration. Likewise, consider the scenario where you have a virtual router in place. So whenever the packet comes from the outside world to the VSX gateway, this VSX gateway, depending on the context determination, it will send that packet to this virtual router, and this virtual router will send that packet to the particular virtual systems. Depending on the source IP, destination IP, source port, destination ports, and protocols, whatever you have configured, based on that it will send to the respective virtual systems. And likewise, if you have only virtual switch configure, so whenever packet come from the outside world to the VSX gateway, based on the VSX gateway and the configuration what you have for the virtual systems, based on the MAC table, MAC forwarding feature, it will forward that packet to the respective destination, whether it's this internal network or a virtual systems. Context determination happens here at the virtual system extension VSX gateway. So this is the rule one, feature one, or you can say the way number one, how the traffic take place. Next point which VSX uses for the traffic management, the second important point is your security enforcement. What do you mean by security enforcement? As we know, each virtual system function as an independent security gateway. Consider this all virtual systems what you have here. This all virtual system individually act as one firewall, right? And this virtual system can manage whatever the network we have behind them, right? Likewise, you can have multiple networks. So this is what the feature what we have with the virtual systems. So virtual system independently manages all the firewalling traffic. So now if we say as each virtual system function as an independent security gateway, obviously they maintain its own unique table, own state table, own security policies and everything to protect their network. So we know all what one firewall can do, and all those functionality is present here on these virtual systems, right? So whatever the designation virtual system we have for a particular network, that will inspect all the traffic which is hitting to that virtual system, no matter where the traffic is forwarding from this virtual router. Consider for now the traffic is hitting to this virtual system. So if the packet comes here, the based on the policy and the configuration what we have, based on that the packet will allow or a block, and based on that it will send to the destination. But here the security policy is taking place. So all this enforcement is handled by the virtual system, and this enforcement is a part of your traffic flow and the traffic management. This is the second feature, guys. Now let's talk about the third and important feature, which is forwarding to the destination. In a traffic management, the third feature, third rule, we call it firewall forwarding traffic to destination. What this mean? As we all know, each virtual system maintain its own unique config. So in that config you will be having firewall rules, you'll be having a routing, you'll be having a netting, you'll be having a VPNs. Based on that, this traffic will be destined to their network. What that mean? Consider this virtual system 1 is managing, say, network 3. Consider whenever packet will come from the outside world to the VSX gateway to the virtual router to the virtual system 1. Here, this virtual system 1, based on the netting, routing, or whatever the configuration we have here, based on that it will forward that to the destination. And this feature is nothing but forwarding to the destination. And guys, based on these three features, number 1, context determination, number 2, security enforcement, and number 3, forwarding to the destination, is perform the work of actual performing the traffic management for the VSX gateway. I hope this video will be knowledgeable for you and you feel it informative. In this video, we are going to see what is virtual system load sharing. We also call it VSLS. In this video, I am going to try to simplify this topic, and I hope you will be able to deliver the work related to VSLS. Let's start with what is VSLS. VSLS stand for virtual system load sharing. If you are planning to set up a VSS cluster and you wanted to have efficient balance of network traffic by distributing the load between the active virtual systems, you need to consider virtual system load sharing option for sure. So it's a definition wise is the same. So VSX cluster can efficiently balance network traffic load by distributing active virtual system between VSX cluster members, and this capacity is known as virtual system load sharing, VSLS. These virtual devices like virtual routers, virtual switch without physical or VLAN interface are not supported when we configure per virtual system state. Let me quickly make you understand about this diagram. Consider we have VSX gateway 1 this is VSX gateway 2, and this is VSX gateway 3, and we have, say, virtual systems. The virtual system number 4, which is at a green state, we can call it like active virtual system, and the virtual system which is at the amber state, we call it standby virtual system, and virtual system which is at gray color, we call it backup virtual system. So consider on one virtual system extension gateway, I have 3 virtual machine configured, and likewise I have 3 VSX gateway, VSX1, VSX2, VSX3, and in these 3 gateways I have also configured 3 virtual systems. Now VSX gateway 1, consider currently this gateway is active. This VSX gateway 2 is standby, and VSX gateway 3 is currently at a backup stage. Okay, so when you set up 3 VSX gateway and you wanted to have a virtual system load sharing feature amongst them, you need to have one VSX gateway always in active state, one VSX gateway always in a standby state, and one VSX gateway always at a backup state. Depending on your requirement, you can set up this sort of configuration. Now similar thing goes with your virtual systems. So the virtual systems which is at the VSX gateway 1, if you have a 3 virtual system there, you will configure one virtual system as an active, one as a standby, one as a backup. But with the VSX gateway 2, you will be having the same sort of scenarios. You will have one active, one standby, one backup. Likewise in VSX 3, you will be having the same sort of scenario, one active, one standby, one backup. I will tell you why this sort of arrangement is needed, but for now just understand this is what the situation will occur when you configure virtual system load sharing. We will going to simplify this, but for now just understand this is the situation. And here if you see this blue link, we call it sync network. Okay, now VSX gateway, you have set up virtual system load sharing clustering. So when you do that, based on the algorithm what Checkpoint have for the VSLS, depending on that algorithm, this arrangement will happen, right? One virtual system, one gateway, one virtual system become active, one become passive, one becomes backup. Whenever the failover occurs, what happens? Consider this VSX gateway goes down, the load will get transferred to the next available standby member. Consider in this case this is the next available standby member. It will become active, right? This is down, and now this was a earlier backup VSX gateway that will become standby. In the event this will come up and you have set up a preemption, then this will member again become active and this member will goes to the standby and this guy goes to the backup, depending on your configuration. This is what happens with when we fail over between the VSX gateway. In the event of virtual systems, so these are the virtual systems, if those get fail, consider this was active on gateway 1, so this gateway 1, this virtual system is active, currently this gateway is active, right? If in case this virtual system get fail, then what will happen, the failover occur and next available active machine from the next gateway will take a preference and that will become active. Now let's understand key points. Number 1, a different member host active peer for each virtual system. What that means, as you can see, at the same time VSX gateway 1 and VSX gateway 2 and VSX gateway 3 can host active member, but the load distribution happens depending on the algorithm what is there. This distribution spread the load equally between the VSX cluster members. What that means, depending on the weight to each virtual system, depending on that weight, the load of the traffic will take place. Consider you have say 30% traffic passing from this VSX virtual system, 60% traffic is passing from this VSX machine, virtual system machine, and then 10% traffic is passing from this virtual system of VSX gateway. This setting you can do by manually changing all this thing, but when we set up a virtual system load sharing, by default equal load distribution happens. So every machine here will take load as per the algorithm setup. So consider one virtual system will take 30%, second will take 30%, and third one will take 40% because 10% is remaining. But equal load distribution, the checkpoint will try to do equal load distribution amongst these virtual systems. That it means about the virtual system load sharing. The load is shared amongst them equally. That is the first key important point. Now, when you create a virtual system, VSX automatically assign standby and backup states to the applicable peer and distribute them between the other VSX cluster members. So when, as I said, when you set up this VSX gateway, and among them if you enable virtual system load sharing algorithm, based on the algorithm what the checkpoint have, depending on that, it automatically assigns the states. So it will make one VSX gateway active, one as a standby, and one as a backup. This is for the VSX gateway, and depending on the virtual systems how many you configure, similar things happens with them also. So one become backup out of the one VSX gateway I'm talking about, one become active, one become standby. Similar thing goes to the VSX gateway 2 for the virtual systems and the VSX gateway 1 virtual systems. So next point, in the event that a VSX cluster member fail, VSLS direct traffic destined to affected virtual system to their fully synchronized standby peers, which then become active. At the same time, a backup virtual system switches to standby and synchronize with the newly active virtual systems. What that means in two scenarios. Number one scenario, consider this VSX gateway got failed. It will transfer the complete load of the traffic to the next standby member, which is fully synchronized. In this case, consider this member is fully synchronized, so the load will transfer to this member, and if in case this also member is synchronized, then the load will distribute amongst this member as well. But in the case this member is not that full synchronized, the load will only transfer to this VSX gateway. Similarly, if the virtual system get failed due to one or the another reason, this virtual system which was active, the next member which is fully synchronized with this virtual system, so consider this one, it become active. So this virtual machine get active, and the next available virtual machine which was acting like a backup, that become a standby. And likewise the other arrangement also happened, like the backup virtual machine changed their state to standby, and the standby virtual machines change their state to the active. It's depending on the what the virtual system priority we have set, and depending on the what algorithms the virtual system load sharing, sharing amongst them, depending on the virtual system extension VSX gateways availability. Next point, in the event that an individual active virtual system fails, it immediately fail over to the standby peer, and one of its backup peer become the standby, synchronizing with the newly active peer. So this failed, then the next standby member become active, provided that standby member is fully synchronized, and the next backup member which was acting as a backup will become a standby, depending on the algorithm what we have set, or depending on the algorithm that what checkpoint have for the VSLS. And the last important point is VSLS lets administrator manually assign virtual system to specified VSX cluster member, or let VSX automatically assign virtual system traffic dynamically. So depending on the administrator's choice, it can set these virtual systems priorities as per his requirement, or we as per the checkpoint algorithm, if you don't do the manual configuration there, it will automatically do the virtual system traffic configuration. So now let's talk about virtual system priority. Virtual system priority refers to the preference regarding which VSX cluster members host a virtual system's active, standby and backup states. This preference is expressed as an integer value. So consider you need to set up a virtual system with the preference when they become active, when they become a standby, when they become a backup. So that preference you can set up using the virtual system priorities. So 0 priority is nothing but the highest priority. So I can write here the 0 is the highest priority, which indicates the cluster designated to the host virtual system is active state. So in this diagram, consider I have a gateway of 150, and in the 150 gateway I have the VSX1 and the VSX5 at 0 priority. That means this virtual system cluster is designated host VS1 and VS5 have the highest priority, and they are at the active state. And the priority with integer 1 is nothing but the second highest priority, which indicating the member designated to the host virtual system is standby. So this is the second highest priority, and whosoever having this priority, so consider VS3 is having this priority from the gateway 150, those are at the standby state. And whatever the priority we will see is greater than 1, we consider that priority as the lower priority. Say consider 2, this is nothing but a lower priority, which indicate the VSX cluster member designated to the host virtual system is at the backup stage. So this VSX2 is at the backup state. Similarly, if you see the other virtual system extension gateways, you will see these priorities, and depending on that you will understand at which gateway which virtual system is acting as a active and the traffic is processing from them. So here if you see number 4, number 6, here like on the gateway 150, those are the active one. In gateway 151, the VSX gateway 151, virtual system 2 is active. In gateway 152, virtual system 3 and 5 is active, right? So the VSX cluster member assigned priority 2 is the first to switch to the virtual system to the standby state in the event of failure, either active or standby virtual systems. So whenever one of the VSX gateway get failed, whatever the virtual system having the priority 2, they become standby. They not become active, they become a standby, and whosoever having the priority 1, they become active. Likewise, the algorithm switches and the priorities get assigned, and in that way you will get the load distribution and sharing features amongst them. And you can use VSX underscore util VSLS command to see all those things from the command line, what we have just discussed about the priority. So this is very crucial and important command. In the lab, I am going to show you this command, but for the understanding, the command VSX underscore util VSLS is the command which we need to run to see all these things. And the last important point here is the wait. So whenever you create a virtual system, with the help of the checkpoint virtual system algorithms, this weight is automatically assigned to the virtual systems. So by default, checkpoint assign weight 10 to each and every virtual system what we have configured. But when you want to have any particular virtual machine get higher weight and do more load of the traffic, to handle more load of traffic, allows you to assign weight to individual virtual systems. So this weight which you are seeing now 10 10 10, you can modify them depending on your requirements. So when you assign a heavier weight to a virtual system, it will gives you a large share of resource on a specific VSX cluster members, and other virtual systems having the less load, maybe sometimes due to the failover scenarios, things hampers. So basically we gives by default weight what what the checkpoint algorithm assigns, and this changes in weight you can also deliver with the command VSX underscore util VSLS. VSX cluster member failure scenario. In this scenario, VSX cluster member 1 fails and its active and standby virtual system fail over to the VSX cluster member 2 and VSX cluster member 3. The active virtual system VS1 moves to the cluster member 2, VSX cluster member 2, and direct all VS1 traffic itself. Its backup peer on VSX cluster member 3 synchronize with the new active virtual system and become a standby. VSX2 on VSX cluster member 2 become the standby and synchronize with the active peer on the VSX cluster member 3. For VS3, the active and standby peer remains the same. And similarly, consider this gateway is active but one of the virtual system get failed. What will happen in a failure scenario where an active virtual system fails on one member but the standby and the backup virtual system remain up? The active virtual system fail over to its standby peer and its backup become the standby. The new standby synchronize with the new active members. So this is what happens when the failure occurs.
Let's see how to configure VSX gateway. Go to that three dots, new, VSX and gateway. Give it a VSX gateway name. Let's give it like a VSX underscore gateway. Give it a IP address 192.168.1.2. Change the version. Right now we have R80.30. So give it a activation key and confirm the activation key and say initialize. It will establish a trust between your VSX gateway. Check the status. It looks good. It says communicating. Next. Now we don't have any VLAN configured, so avoid that. Next. Just have all those policies in place and then click next, and the process of VSX gateway installation will begin. Once you finish, now wait for a minute to this complete. Now operation is complete. Click close and see if your VSX gateway is created. I can see it get created and the license status is yellow, which means that it's evolution license. So guys, thanks for watching this video. I will see you in next video.
I have created one more VSX gateway and installed a policy. Now let's go to gateway and server and create one virtual system. So creation of virtual system is simple. Just you have to right click to the gateway and go ahead with the, or you can go ahead with three dots and just go to the new VSX and the virtual system. Give it a name to the virtual system and the which gateway, VSX gateway, you want that virtual system to be installed.
Next, now add the interface for the VSX. So we are adding interface ETH2 and give it IP address 192.168.1.200 and give it a default mask 255.255.255.0. Select OK. So this interface will be your interface, internal interface, and the main IP address is also the same interface which we have given. Now select next and say finish. So the interface which we have created, using that interface the virtual machine will be communicate to the rest of the world. So it's up to you, like you want to make that interface internal or external, depending on your requirement. You have to deliver that. Depending on that, you have to select the option. So now let's see the virtual system gateway creation is happening. The operation is progress. So let's wait for a minute to complete this operation and we'll resume back.
So the operation is still in progress. Now it's completed successfully. Say close and check if your virtual system is created. Before that, just go ahead and try to see what policy is currently installed onto your virtual system and the VSX gateway, and depending on the the correct policies requirement, install the policy. So I am just going to the VSX gateway and to check what policy we have right now. So right now I am at the expert mode, and let me pull up the policy details. VSX stat -v. If you see here, you can see there is a one VX virtual system present, and it's saying the initial policy installation. Now let's see on the dashboard if we can install the policy. Let's install the policy which we just created, like a standard policy where everything is allowed for the demo purpose. So for now I am just selecting a virtual system and I am just installing the policy to it. So let's wait for the policy installation to get completed.
So look like the policy installation successfully completed. Now let's go ahead into the VSX gateway and check the status of the current policy. So I can see now the standard policy is installed with the VS1, and I think we are now good to do the upgrade. So let me just go ahead and go to the virtual system 1 and check the version there. So right now, as you can see, there is a R80.30 OS installed. For VSX upgrade, VSX and virtual system upgrade, you need to go to the management server, and from the management server you need to deliver this upgrade. So there is a command called VSX_util upgrade. You have to run that command, and once you run this command, you will be prompted for management server IP address where your VSX gateway is installed. I mean, from where you have configured the VSX gateway. So give it a management server IP address. In my case, it's 192.168.1.101. Then it will ask you for the username and the password. Once you give that, it will ask you what VSX gateway to perform the operation. In my case, I want to go for the VSX gateway 2, so I put it number 2, and then it is asking me like which version you want to go. So right now I want to go with the R80.40, and once you give that number 3 is R80.40, the process will start, the upgrade process will start, and you will be seeing the thing on the screen. Most of the time this process get failed somehow due to the one or the another reason, but don't worry about it. Although the process get failed, the upgrade is took place. You can see that in next things. Just wait to complete these things, and I will walk you through. So now I can see the upgrade operation is finished, and I can see the database and everything is got installed. Now it's asking me just if you want to go for the clean installation, and if you say yes, because this is not a VSX what we call, this is not a hotfix installation, it's just the OS installation. So we go with the clean installation, and we'll select the appropriate option for that. Then it will ask you for the activation key. Give it your activation key, confirm your activation key, and once you provide those details, it will proceed for the upgrade. And you will see some failure here, but don't worry about that. It just due to the one or the another reason it get failed, but in background that upgrade process is completed. So as you can see, the process is started, certification revocation is done, and as I said, it's failed due to one or the another reason. So this is the logs where the details of the failed the why it's failed messages get stored. Just go ahead into that and see why it's failed. Probably we'll get the reason that due to the load on module fail, or some silly reason, but don't worry about that. If you check your Gaia OS, you will see that the version upgrade there. Although you might see there is some failures like a sick failure, or the communication between the management server and the gateway is failed, but that is fine. You can reestablish that, and from there you will take it this further. So I'm just into that log files which prompted for us, and if you see, there is something called please check connectivity to the gateway. So that is fine because of the process is delivered. Because of that, it's giving me such error. So if you just open that gateway, and if you see, I can see the R80.40 version now over there. Although I can also see there is something like sick initialization failure. So that only part you need to fix. So next couple of steps I'll be going to perform that to just reestablish a SIG. So just watch those steps, and we'll resume once that is delivered. So I am just giving a go ahead here to reestablish a SIC, and I am giving it a new activation key for my gateway to communicate with the management server. And now I am okay to reboot it. Gateway. Once the gateway is rebooted, we'll join back for the next things. I can see gateway rebooting taking time, but I believe in background everything is delivered. So let me just go ahead and reset the SIC from the smart console and see if I can establish the SIC communication. So let's see. And okay, the trust is established, and I can see the SIC is established between the management server and the VSX gateway. And let me see. Yeah, everything looks good. Now the basic operation is in progress. As every time you do some modification on a gateway object, there is some operation perform in background where the policy or some sort of configuration changes happens. This is the normal process what we can see over there. So let's wait to complete this thing. Still I can see the policy rebooting thing, but I think it's just some sort of error. The operation is got completed, and I can see there is R80.40 VSX version, which is good thing. And we can see the virtual system also is at R80.40 version.
So let's see how we can use VSX util command. So VSX util command has many forms. So one you can see on the screen. You can use it like VSX util with the different use. So this one is for virtual system load sharing, and VSX_util convert cluster. This is for converting your HA cluster to the load sharing. I wanted to show you how this VSX underscore util command for the VSLS works, so that how you can divide your virtual systems between different clusters. So right now, as we've seen, we have a HA cluster. Now we will convert that HA cluster to your load sharing cluster. So for that, I'm just copying this command. Let's log into your management or MDS server. IP address is 192.168.1.254. Okay, give the username admin and the password. Alright, let's go to the expert mode. Okay, let's set expert mode password. Set expert password. Let's enter the expert mode password. Alright, let me save the config so that next time it won't ask me to set the expert mode password. Let's go into the expert mode, expert, and give the password. Oh, sorry. Okay, let me give the password. Let me clear the screen for you and let me increase the size. So now I'm just copy pasting the command, which is VSX util convert cluster. Let's enter. Note the operation you are about to perform changes the information in the management database. Backup the database before continuing. So guys, always remember you have to do the backup first. Here, enter security management server or a multi-domain management server IP address. Always enter your SMS IP address or domain IP address. So I am entering 192.168.1.20 and your smart console username and a password, not the GUI username and password. Okay. All right. Let's see what it shows after this. Alright, save the VSX cluster object. Let's select this one. Enter desired cluster Excel mode, high availability or load sharing. So I want to have a load sharing, so I'm just putting LS. Enter. The per virtual system state mode must be enabled to conclude this operation successfully. Use command cpconfig on each cluster member to verify compliance before continuing with the operation. Proceed with convert. Okay, so this is very important step. So let's better go to your gateway and use this option. Admin, give your password. Oops, expert mode password is right here. No, set expert password. Give the new password. Alright, let me save it first. Save config, done. Go to the expert mode now. On gateway 2. If it's okay, you can run cpconfig from the Flesh also. cpconfig, but I always prefer go to the expert mode because I'm more of an expert mode guy. So let's go to your option, enable checkpoint for virtual system state. It's number 7. So just enter that. Would you like to enable per virtual system state? Yes. Press enter and machine will reboot. Machine will not reboot. You have to manually reboot it to get this in place. Meanwhile, just go to the gateway 1. Here, just log in, admin, your password, cpconfig you can run from here as well. So cpconfig, do the number 7 one option. You want to select yes, enter, well, reboot. Okay, are you sure you want to reboot? Yes, just get rebooted. So let it get reboot, and after this we will go to our MDS, and from here we will say yes to convert your cluster into your HA cluster into load sharing mode. Let me see where we are. Okay, it's getting started. So guys, I'm again requesting you, if you have not subscribed my channel, so please subscribe it, because every day on a day basis or a week basis I'll be putting very important and very deep level content on different firewalls. I started with the checkpoint firewalls, but I'll be putting on a different firewalls, as well as into the network security areas, into the cloud areas, into the whatever we have in a cyber security. I'll be putting a lot of videos and high level content which will be very useful for your job career. Whenever people will ask you regarding the questions on this technology, it will be very handy for you to give them the answer. So please subscribe my channel and press that bell icon so that you can get my latest video as soon as I release. Let's wait for some time to get this thing started. Okay, this is started. Let the other system also get started. Gateway 1, it will start in a moment. Just wait for it. Starting the system. Also note when the system gets started, some driver inside they get loaded, so you don't have to do hurry here. You have to wait at least couple of seconds after the system is started. So I usually wait for 5 seconds. Once this gets started, I think we are good to go now with the command here. So I'm saying yes to this. Proceed with conversion. After converting the cluster, the command VSX util VSL virtual VSLS may be the used to virtual system distribution and export. Enter the distribution option 1 or 2. 1 is saying distribute all virtual systems so that each cluster member is equal loaded. Set all the virtual system as active on the same cluster member. So let's do the second one for now. Okay, let's wait it proceed with that option. Okay, taking some time, but it's worth to wait to see that thing come up. So this content you may not get on on a daily checkpoint thing. So yeah, now the cluster was successfully converted to the cluster as load sharing mode, and now it's installing the policy. So guys, just now we have used a utility as I shown you how you can convert your HA cluster into load sharing mode. Okay, so I think I am pausing this video now, and I'll be go back again. I'll be come back again with the VSX util VSLS option. You will see a lot of things on this part also. All right. So guys, I have created two virtual systems for the demo purpose. If you don't know how to create the virtual system, you can refer my previous videos. For now, I am showing you VSX util VSLS command use. So let's jump into that. We need to go to the MDS and from there to the expert mode. And once you are in expert mode, you have to use the command. It's VSLS underscore util space VSLS. That is the command name. So let me type VSX underscore util space VSLS. Enter. Now it will ask you to put your domain IP address. Remember, we need to put a domain IP address, not the MDS IP address here. So it's 192.168.1.20. Enter your smart console username password. So I have to use okay, it's the variable, right? So I think I need to again rerun the command. So let's put this time the correct username and the password. One 192.168.1.20. Username is Vaibhav and the password is, I will not tell you the password I have put. And okay, I can see the cluster now. Just put the number one option, you will see different options here. So display the current virtual load sharing configuration, number one option. Number two, distribute all the virtual systems so that each cluster member is equally loaded. Set all VSX active on one member. Number three option, manually set priority and wait. These are the, if you read my screen, you will see all those options. So basically so let me log into the gateway again and just wanted to see some stuff. Expert password, cpconfig. I think yeah, the number 7 option is already there. So we already put it our gateway in a load sharing state, virtual load sharing state. Let's see what is the state of the cluster. Okay, it looks like active standby. Let me just go to the gateway 1. Okay, here also the number 7 option is there. Go to the VS1 and type cpconfig. It's there. Okay, so number 7 option is already there, so we are good to go from this side. You know, when we are in a load sharing mode, this disable checkpoint per virtual system set, that has that option need to be there. Number 7, keep in mind. Okay, let me see what cpconfig option again says. Okay, it looks good. It looks good. So I think we are good to run that VSLS VSX underscore util VSLS, and we will able to see the load distribution. Let me reboot the gateway in case that number 7 option is, or let me cp start or cp start in case that number 7 option is not, you know, took place. Let me do the same with the gateway 2 in case, because if that option from the cp config is not uh, set properly, you won't be able to get the right answer from that VSX util underscore VSX underscore util VSLS command. So just wait to gateway to be rebooted. Okay, it will take a couple of seconds. Just wait. Yes, when the formation stop, I think cp stop has done. Now it will start all the processes and it's getting started. Okay, installing the policy, fetching the policy. Let the policy get fetched. Okay, installing the policy on the gateway 2. Let the policy get installed. So guys, this will be little bit longer video, but the end result will be the one which we actually wanted to see. So I think it's get the process are getting the file is started now. Gateway 2 is started. This drop spec. Okay, HA module is not started. So some of the another reason I don't see the HA is not started between the VS, because we already enabled that virtual system load sharing mode, but still it's not started. So guys, bear with me for some time to see if I can fix this issue. I think gateways are rebooted, all options are set. Uh, let's quickly go to the your MDS and again try to run the command VSX underscore util VSLS. Let's see. Put your domain IP address 192.168.1.20 and your username Weibo, the password for Weibo username. Let's see what we can see now. Let's select option 1. Let's select the option 2 here, distribute our virtual system so that each cluster member is equally loaded. Policy instruction required to apply the configuration. Make sure the cluster member are up and reachable before continuing. So I'm saying yes. Let's see if it works for us. Alright. VS load sharing configuration saved successfully. Virtual system were successfully redistributed and installing the new policy now. Okay. Let's wait for a couple of seconds so that the policy get reinstalled. So when you play with the virtual system VS, you have to be very careful about your configuration. If you are doing all these things in your production environment, you need to have a proper downtime and proper understanding so that you can do this thing well without impacting your production environment. Okay, so I think we are good now. Let's see the save and exit the distribution. And if you want to see what the process and everything result, you will go to this uh, directory and check this file. Let me see. V with the checkbox state is given the same. But anyhow, you got the understanding that how this VSLS work and how you can perform these operations.